Good afternoon, dear students. In the last class, we discussed about the acceleration and the speed and acceleration. So now we will discuss about the graphical representation of the motion. So, so how the graphically we can represent the motion. Graphs provide a convenient method to present basic information about a variety of events. For example, the telecast of the one-day cricket match. Now the IPL is famous, I think. So in the IPL match, you may see that the graph. They'll show the graph. So the run rate of the batsman or the wicket fallen, all those things they'll show. So when they show like that, it is very easy to analyze the entire match. So at what is the run rate of the match, or what is the who is the highest who's the who scored highest, who taken maximum wickets, all these things we can see in the graph. It is very easy for us. So here for the telecast of the one day cricket match, the vertical bars shows the run rate of a team in each over, as you have studied in mathematics. A straight line graph helps in solving a linear equation having two variables. To describe the motion of an object, we can use the line graphs. In this case, line graph shows dependency on of one physical quantity such that distance or velocity on other such as time. So here in this graphical representation we have two types of graphs. Already this type of this thing is learnt in your 8th grade, 8th standard. The same thing is repeating here also again. So it's a distance time graph, that is dt graph you can call it as, and also you can call this as a dt graph, distance time graph. Okay, so the change in the position of an object with the time can be represented on the basis on the basis on the basis of represented on the distance time graph, adopting a convenient scale of choice. In this graph, time is taken along the x-axis and distance is along the y-axis. So the distance time graph can be employed under the various conditions where objects moves with uniform speed, non-uniform speed, remains at rest, etc. So here the distance time graph they given. See here. So this is the time. So the time here they mention in terms of minutes. So therefore this first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each division is 2 minutes. So therefore the graph is at this point. So and here also each division is, I think, 1, 2, 3, 4, 5. Okay, each division is 2 kilometers. So if we draw a straight line like this, so here I can find the distance. How? At the 1, 2, 3, 4, 5, 6. At the 6, in the sense that at 12 minutes, it's a 12 minute, the distance traveled by this is 8 kilometers. So in 12 kilometer in 12 minutes, the distance traveled by some object is 8 kilometers. So like that we can find the distance graph. So now if we see this straight line, we may say that that object is traveling in a uniform motion. So in a graph, if we get a straight line like this, we can say it is a uniform motion. But if we got a graph like this curve graph, if it is curve graph, we can say it is a non-uniform motion. So now this is called as a dt graph or distance time graph. Why? Because it is plotted distance and time, distance versus time. So in the x-axis we have time, in the y-axis we have distance. So we can call this as a distance time graph. Instead of here, if the velocity is there in the y-axis, then we can call this as a vt graph or velocity time graph. I hope all of you understood this. So this is a distance time graph. So the distance time graph, an object moving with a uniform speed. There is no change in the speed. The object is moving in a uniform speed. So then we'll get the distance as, so then we'll get the straight line like this. So if the distance and time the distance and time graph of an object moving with a uniform speed. If an object is moving in a uniform speed, you will get a distance time graph like this. It's a straight line. Okay, so now suppose the distance the distance time graph for a car moving along a non-uniform motion. If the car is moving in a non-uniform motion, so then the graph, if you plot a graph that is distance versus time, so you'll get a curve like this. You'll not get a straight line. So only you'll get a straight line for a uniform motion, and for non-uniform motion you'll get a curve like this. I hope all of you understood. Okay, this is the distance time graph for a car moving with a non-uniform speed. So this is for the uniform speed. Okay, I hope all of you understood this. Okay, so then we'll move on next.